All right, in our last video of the unit, for part 1 of 4, I should specify, is we're going to apply what we know about linear equations, and let's see what it looks like into like a real life scenario. So in our first example, it says Tanya has $100 saved in a bank, then she gets a job working at Starbucks and she earns $50 a week. They actually give me the equation that says y equals 100 plus 50x, where y is how much is in the account and x is the number of paychecks. Excuse me. So in A, it says, well, what's the initial amount in the bank? That initial amount is $100. Notice how that's also your y-intercept. Okay, those two kind of go hand in hand. What is the rate at which the account is increasing? Well, she's earning $50 every week. Okay, so $50 per week. Okay, notice this is also your slope, which is your rate of change. Those are the same things. So now we're going to use a table. So we're kind of like taking all of our videos and putting it into one. So now we're going to use a table to figure out how much money is saved. So after 1 week, or actually, I'm sorry, 0 weeks, where is she starting at? That's at $100. After 1 week, it's at $150, because it's just going up by 50s, right? Then $200, then $250, $300, $350, and finally, I was going to say $600, $400, okay? So now that we've got this great table, we're going to go ahead and pull out this on our graph. Now we want to be able to label each axis. So I think we got to think back to Unit 3. What depends on the other? Remember, your y is your dependent. So this is going to be money saved, right? The money saved depends on the time or the weeks. So now the money saved, I have to be able to fit 400 in here, right? So let's see if we can go up by 50s. So if this is 50, this is 100. If this is 150, this is 200, 250, 300, 350, perfect, 400. And that's really nice because my slope is 50, and then, going up by 50s. And so my weeks, here, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So initially, right, I'm at 100, or the point 0 and 100. Then I go to 1 and 150, 2, 200, 3 and 250, I should say, 4 and 300, 5 and 350, and 6 and 400. Nice and straight. Okay, so what does the slope represent in this example? Well, my slope is how much we're earning. So earning $50 per week. Well, what does the point 4 and 300 mean? So remember, 4 is your x value. So that is the number of weeks. And the 300 represents your money. So in a complete sentence, I would say, after 4 weeks of working, Tanya, right? That's her name, right? Tanya has saved, let's see, $300, or has $300 in her account. So let's look at one more example before you try one on your own. So it says, Courtney has been feeding her cat, Rocket, way too much food. So one day, Kylie decides to weigh him and finds that he is 27 pounds. Holy cow. He puts him on a strict diet. Since then, Rocket has been losing 3 pounds every month. Okay, so first of all, let's talk about what my equation would be. Okay, so my initial amount is 27 pounds. Okay, what is the rate at which he's losing weight? Key here is losing. Well, it's 3 pounds a week. So 3 pounds, or what did it say a month? 3 pounds per month. So what I would actually do is I would actually take that information and create an equation. So it would be y equals, or his weight is equal to his starting, and then he's losing weight 3 pounds every month. Okay. So at the beginning, when we haven't even started, he starts off at 27 pounds. Okay. After a month, or I'm deducting 3, he's now at 24. Right. Then at 21. Then at 18, 15, and eventually 12. We don't want to get down to 0, right? Because that's impossible and unhealthy. So now we're going to graph. Okay, and so remember that his weight depends on time or the number of months. So his weight has to be able to get up to 27. So let's go up by 3s. Okay, let's see if that even fits. So this would be 3, 6, 9, 12, 15, 18, 21. Let's see, 24. And then, perfect, 27. Okay, and then my months will go up by just 1s, 1, 2, 3, 4, and then 5. And let's see, so we start at 0 and 27. There's his starting weight. Then we go down 3. So in this case, that's just really down 1. That's equivalent to 3 and over 1. Okay, because this is 24. Then in the next month, he's at 21. Then at 18. Then at 15. And eventually 12. And I'm just going to connect those points. It would ideally keep going, but we don't want to get him to 0 pounds, right? And so the slope in this example represents how much weight he's losing per month. So I'd say how much weight, in this case, is 3 pounds. Okay. What's the cat's name? Rocket. Loses per month. And what does the point 221 represent? That would mean after 2 months of being on his diet, after 2 months on diet, okay, Rocket weighs 21 pounds. So why don't you guys try the next one on your own? So Jamie decided to spend the day at the North Carolina State Fair. Oh, state spelled wrong. Don't mind that. She paid the entrance fee into the fair, which was $10, and each ride was then $3. The equation is modeled here, where Y is the total cost and X is the number of rides. So we'll go ahead and graph the information. Now, interestingly enough, we don't have to make a table here. So we got to remember our slope. And my slope is 3, and my y-intercept is 10. So let's see. So my cost is going to depend on the number of rides I go on. Number of rides. So I'm going to go up by, let's do 3. So 3, 6, 9, 12, 15, 18, 21, 24, 27, gets all the way up to 30. Perfect. Now my y-intercept is 10. So I have to kind of make that estimation. It's about right here. Okay. Now I'm going to go up 3 and over 1. So from 10 to 3, up plus 3 is 13 per 1 ride. Oh, and I just realized I didn't label this. 1, 2, 3, 4. Okay. So then I'll go up from there. So after 2 rides, okay, that'll put me at 16. After 3 rides, that'll put me at 19. And then after 4 rides, let's see, that'll put me at 22. Kind of just estimating where I'm putting those points. Now your graph might look different than mine just because you chose to go up by different numbers. So part B, if she went on 7 rides, how much did she spend? So I could use my graph. So let's see, 5, 6, and 7. I notice a pattern. I'm just kind of going up 1 and over 1. So I can tell from my graph that she will have gone on, or she'll have spent $28. Okay, but I could also go like this: y equals 10 plus 3 times 7, which would just be 10 plus 21. Ooh, hold on a second. Did I do something wrong? I'm going to backtrack here. No, I think I did something wrong. Oh, haha, duh. That would be 31. Hold on, I had a moment of panic. But I feel like I did something wrong on my graph here. Let's see. So at 1, she is at 13. At 2, she's at 16. At 3, she is at 19. At 4, so 4 times 3 is 12 and 22. And then 5 times 3 is 15 plus 10 is 25. And then, how did I mess this up? And then, oh, because I only went to 6, y'all. Oh my goodness. Okay. That's why. See, I knew I messed up somewhere. It would be right here. Aha. There we go. That's better. Okay. Whew. I was worried there for a second. Okay, and then for the last question, what does slope of the line represent? So my slope in this case is the cost per ride. And that's it.